This video is about volume of a rectangular prism and goes along with CPM Chapter 9, Section 1.1 for 6th grade. There are a few important terms that you need to know as we go through this lesson. The first one is one dimension, and that's something where like an object has length but no width or height, and that could be something like a line where it has one dimension. If you look at something that's two dimensions, that means that it has that length and it has a width, but it has no height. So an example might be a rectangle. When it has three dimensions, it has length, width, and height. It might be something like a cube. A Rubik's Cube might be a good example of a three-dimensional figure, especially as you're working through this lesson, because you're able to look at all the units on the length, on the width, and on the height. So when we then look at volume, what that is, it's the number of cubes it takes to fill a three-dimensional object. Okay, the formula for volume is the length times the width times the height. And you need to know that formula as we work through it. Okay, when we think about volume, do note that it is how much space can go into something. If we took the Rubik's Cube, we could count how many cubes are inside the Rubik's Cube. Don't confuse that with surface area, which would be how many stickers do we need in order to cover the Rubik's Cube. So let's look at some problems with that. Danny is making brownies in an 8-inch by 8-inch pan. If she uses one bag of brownie mix, the batter is 1 inch above the bottom of the pan after they finish baking. How many brownies will she have if she cuts the entire pan into 1-inch cubes? So do remember that this is a three-dimensional figure. You have your width, which is 8 inches. You have your length, which is 8 inches. And you have your height, which is 1 inch. And then what I want us to do is I want us to write the formula. So we have volume is length times width times height. And in my class, we've been talking about going over the givens. Okay, so I'll put that over here, where we have our length is 8 inches, our width is 8 inches, and our height is 1 inch. And then we can say what we're looking for, and that's the volume, which we don't know. And remember that is inches, but it's going to be inches cubed because we have three dimensions. Remember, when we look at a two-dimensional figure, when we look at the area for that, that's squared because we have two dimensions. With volume, we have three dimensions. And from here, we can plug that into the problem and solve it. So when we solve this, we can work our way through that upside-down triangle that we've been talking about in class before. And we see that we have 64 cubic inches. But does that answer the question? Let's come back to the question. It says, how many brownies will she have if she cuts them into 1-inch cube? Right here we have 64 cubic inches, but we need to write that again as we have 64 brownies. And that is our solution here. And we need 64 brownies. Now, what if we said that Danny was using 2 bags of brownie mix? Okay, go ahead and rewrite your givens for that and try solving the problem, and I'll show you how I would do it. So when we work through this, writing the givens again, our length doesn't change. We're still using the same pan. Our width doesn't change. Again, we're still using the same pan. Our height does change. We know that one bag is 1 inch tall, so 2 bags should be 2 inches tall. We're still looking for the volume, and we're still looking for the number of brownies. And from there, we're then able to rewrite our formula. Volume is length times width times height, and then plug it in and solve it. When we go through and solve it, once again using that upside down triangle, we find that we have 128 cubic inches, which gives us 128 brownies. And do remember, we're still cutting them into 1-inch cubes. Try another problem. Mr. Funk went swimming in a shark tank. If the tank was 12 feet long, 3 feet wide, and 4 feet tall, how many cubic feet of water could fill or fit in the tank? How many would fill the tank? Write your given, solve the problem, and then I'll show you how I would do it. Okay, the first thing that I did is I wrote my givens. I have my length is 12 feet, width is 3 feet, height is 4 feet. I included the formula for volume, and I included what I'm looking for. Now I'm going to go through and solve it. And when I go through and solve this, once again, I'm using that upside down triangle. Okay, 12 feet times 3 feet gives you 36 feet, times 4 feet gives you 144 cubic feet. Okay, and that's where our solution ends here, because it is asking how many cubic feet. It's not asking how many buckets of water. It's not asking how many gallons of water right now. It's just asking for cubic feet. I want you to try this problem and draw a picture with it, and then I'll show you how, because it changes how you look at it a little bit. Students were working on volume problems in the classroom. The teacher has only quarter-inch cubes. How many of the teacher's cubes would go into a 1-inch cube? Again, draw a quick picture and then try to solve the problem. When you did your drawing, it might look something like this, where you have a smaller cube and a larger cube. The reason that I wanted you to do that is so that you could see that the smaller one will go in multiple times. And another way you could represent that is with a cube like this one, where you can say that this is going to be one side, okay? And we know that quarter-inch is going to go in to one face 4 times, okay? So your width is going to be 4 of the quarter-inch cubes, okay? And your length is actually going to be the same as well, because remember, cubes are the length, width, and height are exactly the same. Okay, so we're going to have 4 of those quarter-inch cubes once again. And the height, okay, once again is going to be exactly the same. So if we have the width, the length, and the height, and all those you need 4 quarter-inch cubes, we can then use our volume formula to figure out how many there are. So we have our length, we have our width, and we have our height, and then we can just plug the numbers in. So we have 4 cubes for the length, 4 cubes for the width, and 4 cubes for the height. And then as we solve it, we are able to go from there. And we'll see that we have 64 of those cubes. Okay, and remember, it does say how many of the cubes. It doesn't ask you for cubic inches. Okay, so as we look there, you will need 64 cubes for a 1-inch cube if the smaller cubes are 1/4 of an inch.